Second.
Oh, right.
We'll start again.
What?
Good evening. Welcome to Space Oddities. We've had a slight technical problem here, but we are now with you. So basically, we need to start again. Good evening. We hope you're all okay out there in YouTube land. And I'm joined this evening by a few people, the usual suspects, plus a guest. That guest being Dave Saris, who you may remember is an old friend of Space Oddities. I've got Daz with me this evening. How are you?
I'm lovely, thank you, and I hope
Well,
everybody's well. And expecting a load of astronomy to be thrown at them.
right. Okay. Yes. Well, we're certainly going to try and do that. Roger, how are you?
I'm fine, thank you.
Jolly good. And we've got Lou.
Despite what they say.
Yeah, exactly. Got Lou from the States. How are you, Lou?
Doing well, readying for the eclipse.
Yeah, and we're going to hear a bit more about the eclipse a little later. And last but not least, we come to NPay Dave. Dave, can you just explain a little about NPay for the benefit of viewers who are not familiar with what you do? Right. We seem to have a communication problem with Dave. We had it earlier, so I don't know how we're going to get around this. I know
Hi,
Dave's
everybody. So NPay is a UK-based engineering firm that manufactures specialist telescope accessories. Oh no, it's not working, is it?
It's we've got problems
Let me
with.
change my internet connection.
Okay, yeah, because you've got a huge delay on your sound. Okay, well, we'll come back to Dave. In the meantime, let me tell you what we've got lined up for you. As long as we can get Dave back and his connection working okay, we've got a little presentation from Dave about the Florida Winter Star Party, which he recently attended, so we'll be hearing all about that. We've got also a presentation about the upcoming total eclipse of the sun from Lou, visible in the United States, of course, and I'm sure eagerly awaited by millions of people there. And I've even been reading articles recently that say it could be the best total solar eclipse in hundreds of years. So let's hope that's the case. And Daz, a little later, is going to be telling us about the aurora that didn't happen the other day after a massive outburst on the sun, and he's going to be describing exactly why we didn't get a lot of aurora activity, even though it was quite a severe outburst, severe solar storm. So that sounds interesting. So we'll come back to that. In the meantime, what we're going to do is go straight over, of course, to the man with the mostest, that being Roger. So, Roger, what's up in the night sky this week?
Right, okay. So here we go for the final part of March and into eclipse month. So the big eclipse will be on Monday week. Not too far away. I know. Good, isn't it? Had the full worm moon, as they like to say in Native American circles, and heading towards the last quarter on the 1st of April. And this was what I could see through the only brief piece of cloud that I could get the moon, which was only 2 days ago. So there we go. So through the week, we've still got Jupiter, although it is now diminishing towards the western skies, and Orion following onwards from there. But we do have the galaxy constellations of Virgo and Leo coming up into the southern areas of the night sky. So something good has come of that. And obviously, as we progress through, we're getting to start to see the summer triangle coming up through. But enough of that. Wishing my life away. Now, the reason we've got only 2 planets visible in the evening, because everything's gathered around the sun almost. We've got Mars, Saturn, Venus. We have got Neptune about somewhere, and we've also got Mercury. We can't quite see the sky just like this, but I've just done the atmospheric effect to show you how close they are to where the sun is. So obviously we'll have to wait till the autumn winter period for these to return to the evening skies to get the full advantage of them. And as you can see, we are, and as you can see, that at the weekend we've got the clocks going forward, so another hour of darkness lost to us astrophotographers. But at the moment, we've still got the opportunity to capture Pons Brooks, which is in the constellation of Aries. It has been going through past Galaxy and also M33 and Triangulum, which there were some quite interesting photo opportunities, but it's still quite good. And if you've got binoculars, you should be able to see it quite well. It's still brightening up, and it's coming up to magnitude 5. And obviously, the further on it goes, will become more of a southern hemisphere object, and it might get to an opportunity of maybe down to 4, but that's always an optimistic call. But this one, which will become much brighter towards later in the year, is Comet Christensen Atlas, which is in Virgo at the moment, and that's still not quite as bright. It's not as pretty as the other one, but it is gradually working its way through the magnitude scale. And as you can see, between March 26th and April the 19th, it's gained 1 magnitude in brightness, and should be almost as bright as Venus, if you can believe that, somewhere in the autumn. But that's a matter of wait. I'll wait and see.
Yeah.
But we have had some new information from the web, and this is NGC 4756.
Wow, that's beautiful.
Which is which has got a Cepheid variable in here, and here we have a comparison between the Hubble and the Webb on the resolution of finding that object.
That's amazing.
Even though it is pixelated, but the resolution is still evident. And then we've got this one, which is a rather interesting object.
Wow.
Yeah.
So there's some new young protostars forming in this region, which is quite interesting. Yeah, quite fascinating.
Yeah, I think I saw a bigger version of that one, and there was some really large diffraction spikes, like the one you've got on the star just at the top there, and
looking more like a snowflake like that.
Exactly. But this had really long, extended diffractions. It was a bigger image, and so I'll have to pop on there and have a look, see what we can see about that. That's nice.
Okay, but we have a larger gallery, obviously, with the lack of presentation of it last week. So bear with us. So we've got a few from Sonia. This is one of hers of Comet Pons Brooks, which was 63 minutes in total with her C star.
Nice.
And here we go.
That's nice detail in the tail. Yeah.
Yep. Very good. Quite impressed.
Yeah, I managed to catch it with my C star, but the sky wasn't that brilliant. You can just make out the tail, but that's fantastic.
I know the C star can have some problems with color correction. I wonder if these colors, the green and the slightly purplish tail, are accurate.
With the ones I had, the head, was it called comma? The comma.
Yeah, the coma
was very green, and that was in a sky that was hazy rather than completely clear. But I only got about 15 minutes on it. But that just goes to show what you can achieve using the C star.
Beautiful.
Okay, so we've got one here from Jerry, straight plus 284 in Monoceros. And this is what we've got here.
Whoa. Very nice, Jerry.
Quite interesting, that one.
Yeah, isn't it?
That is.
It's not a bit off the beaten track, that one. So it's interesting always to see something new.
Yeah, that's really.
Certainly is.
That's quite spooky, that, isn't it?
Yeah.
Is it monoceros or monoceros?
Monoceros.
Rhinoceros. A bit like rhinoceros.
Yeah.
Tomato,
And here's
tomato.
one. Here's an older picture that Sonia had taken as a reminder of what currently is visible in the night sky. So this is Hale-Bopp.
Gosh.
I remember that one. Yeah,
And
97.
Yeah,
and that's the camera that she took it with.
yeah. The
Yeah,
Fujita.
I've got a really beautiful one of Hale-Bopp somewhere taken from my garden. It was that was the comet of the century. That was unbelievable.
That was a great one. I remember it well.
Yeah.
And it hung around in the night sky for what seemed like forever.
And here's one with her 10-inch Dob and her Google Pixel Pro of the moon, with the lunar V and X visible.
Oh,
So it is.
Yeah.
that's
It
They're
is.
both
right.
there. Yeah,
Yep,
fantastic.
both there, quite plainly to see.
Yeah.
Very good. Okay. And Chris Reardon, the Pac-Man in Cassiopeia from November.
Oh, look at that!
And
Look at the colours on that.
This is a starless version.
Yeah, and Bible Black. Sorry, show me image there.
Okay.
Gorgeous.
See, this is another one where you could dispute what it's called, Cassiopeia or Cassiopeia.
Cassiopeia. She told me herself. Another one from Sonia. 99% moon. Very nice. Look at that.
That's nice.
That is nice, isn't it?
Yeah.
Beautiful.
Have we lost Rog?
Yeah, Roger, we can't hear you again. You've lost your microphone again. Oh.
Yeah, he was on his Bluetooth and it was playing up, wasn't it? I was taking it off now.
Yeah. Okay. I wonder if this Roger Hyman is any relation to him.
Oh, sounds like a pirate name, doesn't it?
Yeah.
Yeah.
So
Still can't hear you, Rog.
No,
Oh, look at that.
There we are. That's the comet. That's the baby. Very nice indeed.
Wow,
Very
that's
nice.
a good one. That is. That's an amazing coma.
Yeah,
Isn't
and
it?
that also shows how really long the tail is. You can just see it faintly stretching away.
Yeah.
That is really. In fact, you can probably see a second tail just slightly slanting off to the right there. Yeah, that's
Is
fantastic.
that the ion tail? It must
Yeah,
be.
well,
Probably, yes.
Yeah.
Oh, he's back.
I'm back.
Ah, hello.
I'll be back.
You're back.
I'm back. Okay.
Uh-huh.
And final one is some solar images, white light and hydrogen alpha.
Oh.
Yeah, of course. It's the two sunspot regions on the right. They're the ones who have been giving us. Well, ever since they came on to the face, they've been firing off flares of different sizes.
Yeah.
And the other day, which gave us they actually flared together. That's what gave us the some fun and games.
Yeah. There was up to 52 spots in that area.
Yeah. This is 3614 and 3615. They were designated. In fact, the one at the top on the top right, that's our old friend 3590, which gave us fun and games when it last came around. It survived its trek around the back of the sun, and it's come around again. And also these two next to it on the left, there was about 4 of them all in a straight line, and two of them have survived.
Amazing. Lovely images.
And there was quite a lot of prominence action on the go as well through the week as well.
Through the week, it's been really busy. What's been coming onto the sun's face and going off of as well. There were some lovely arches. You could see the actual matter flowing between them, the plasma flowing around along the slides. A lot really happened last week. but a lot of it missed us because it was not going towards the north, so it missed us. But we did get to the show on Saturday, or we didn't get the show, but we'll talk about that later.
Yes. Right. That concludes my presentation.
Thank you very much, as ever, Roger. Good stuff. Thank you, viewers, for sending in your images.
Yeah,
and as ever, if you would like to send us your images and haven't done so before, it's simplicity itself. Simply attach your image, one image per email, please. Attach it to an email. Address it to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And be sure to put in the subject of the email somewhere the word gallery, and that way it'll get picked up automatically and put in the right place, ready for Roger or Rachel to pull it out and put it in the presentation, for which we thank them, obviously, for their tireless efforts in keeping the gallery going. And we do intend to keep the gallery going because we absolutely adore looking at your images. So email us your images. And it doesn't matter whether you're just starting in astrophotography or whether you're a seasoned, experienced astrophotographer. We just love looking at images of the universe. And there we are. If you could get those to us by the end of Sunday, that would be fantastic, which will give Roger or Rachel, or depending who's doing it, time to sort the images out ready for tonight's show, or the Tuesday show, should I say. So if you could get us the images by the end of Sunday, that would be much appreciated. If they do arrive late and Roger or Rachel are not able to find the time to put them in the gallery, we'll hold them over until the next week. But don't worry, if you send us an image, it will be featured in the gallery. Wonderful. We'd like to thank you all for your continued caffeine injections. Thank you to those of you who buy us coffees. We do appreciate it. As I always say, it keeps Space Oddities on the road because we have bills to pay, like any other YouTube channel has bills to pay. So thank you very much for your contributions. I'd like to also, if you weren't already aware, there is another way that you can donate to Space Oddities. And if you look on YouTube, you'll see an icon there labeled Super Chat. Now, the Super Chat option is designed for those YouTube channels, and I'm sure you've all seen them, where the live chat window is scrolling up so fast because there are so many people posting there that you can't read the posts. And what the Super Chat allows you to do is have your message highlighted and put to the top of the pile so that it's brought to people's attention. Well, we don't have that many people yet on the Super Chat, on the live chat on our shows. But if you would like to donate to Space Oddities, that's a way of doing it. And you click that and it'll take you to the payment page. Would like to say thank you to Gerard very much for trying out this feature and donating. We do appreciate it, Gerard. So thank you very much. You're a hero at Space Oddities. We're going to put a picture of you on the wall if you want to send us a suitable picture. It'll be framed. So there we are. Gazakroy says, I'm not far off 60 in just my first telescope, only a small one. Well, listen, you all have to start somewhere. Yep. And, I started with a very cheap 2-inch refractor and moved up from there. So good luck with your hobby. We hope you enjoy it. And thank you for that.
Now, with 2 magnifying glasses and a toilet roll tube.
Right, Dave, you're back. Dave, okay,
I'm back.
I'll come to you in a second, Dave. So the other way, of course, is to, as ever, buy us a coffee. And there's the QR code you can scan to buy us a coffee. All donations gratefully appreciated. If you look in the live chat window, there will be a link there that has just appeared for this as well, if you don't want to scan the QR code. Don't forget the good old Space Oddities merchandise that Daz and myself are wearing this evening. So let's just prove it. There we are.
Was that it? You got a crop top. That's what you do when you go too high.
Yeah, I haven't got a tent like you. So the Space Oddities tent Daz is wearing tonight.
Hey, mine's made by Cameron Balloons.
That must have been a good year. So the Space Oddities T-shirt, yes, 10 colours available. This will cost you a virtually negligible sum of £20, including UK postage and packing. And it has the Space Oddities design on the front. We also have the Space Oddities hoodies, 6 colours available, and these are £40, including UK postage and packing. They come in 2 designs, the zipper type where the design is on the back, and the over-the-head design where the design is on the front. And as I said, £40, including UK postage and packing. You can scan the QR code that's on you see on the screen now, or if you look in the live chat, a link would have just appeared as well. Also, the latest addition to our range of desirable fashion, the Lapel design T-shirt, 10 colours available. This is where the design is at the lapel, as its name suggests. And again, like the T-shirts, these are £20, including UK postage and packing. If you are ordering from abroad, please add £10 per order to the total value. And there we are.
Yeah, there is a long sleeve version of that as well.
Oh, yes, sorry. Yes, there is a long sleeve. Let me put that back up on the screen. There is a long sleeve version of this available. And if you want long sleeves, it's going to cost you £3 extra. So these will be £23, again, including UK postage and packing. You pay £3 for those extra bit of sleeves, which personally I think is an absolute bargain. So there you are. Hopefully, with the weather improving now, you won't need the long sleeves version before too long. But we advise you to buy them, obviously, before next winter. Get them in for next winter. Okay, don't forget, please, to like and subscribe, because it really does help to keep the show on the road. If you like and subscribe and comment on the video on YouTube, that helps us get noticed by the YouTube algorithm, and therefore our videos will be recommended to more people. And Gerard says, I refrain from sending a photo as I would not wish it on my worst enemy. Well, you'll be the best judge of that, Gerard, I'm sure. So
Thank you for the super chat.
Yeah, so there we are. Let me just go back and just have a look and see here. And as you said, Gerard has got us another super chat. Thank you so much, Gerard. That really is appreciated. So you've gone even higher in our estimation, if that were possible. All right. So moving on. Let's get back to Dave. Let's see if we can actually get Dave's vision synchronized with his sound, because before we were thinking that he was on Mars because there was a time lag in the signal. But Dave, you're welcome back to Space Oddities. Thank you for being here this evening.
Am I synchronized? My sound and video is okay now?
Just about. You've still got a bit of a lag, but and you're a bit pixelated, but we'll struggle on regardless. So, as I was trying to say earlier, could you tell us a bit about what NPay is all about?
Sure. So NPay is a UK-based manufacturer of telescope accessories.
Right. There you are, in a nutshell.
In a nutshell, it's all unique stuff. It's all designed and manufactured in the UK, and we specialize in diagonals and eyepiece turrets.
Right. Great. And we'll be seeing some of your products during your presentation a little later. So let's move on now. What we're going to do now is go over to the news. We didn't have news last week because we were mainly talking about the Starship flight. But we are fully replete with news this evening. So let me just get myself sorted out here. And we will have a look at the news. So the first item on the news, a bit of a shock. The venerable, legendary Chandra X-ray telescope is going to be axed by NASA. They've made this decision. The reason they've cited is that they need to balance the portfolio in the light of budget cuts. Now, NASA didn't get the amount that they wanted in this year's budget, and they unfortunately have to balance things, as they say. But a lot of astronomers are really angry about this, and because Chandra is the only high-resolution X-ray observatory that we have. And, if we lose Chandra, then the whole field of X-ray astronomy is going to suffer a lot. The axe is going to fall at the end of 2025, but the budget for Chandra will shrink significantly year by year before that. which is just a bit of a disaster. Another reason given for NASA, they had to come up with some technical reason why it had to be axed, and they say that the telescope's thermal management is failing. It was launched in 1999, so it's getting on in years. But the managers of the telescope say they've got that under control. They've got a plan that they've already partly implemented, which is controlling the thermal management, and they say that it can last for at least another 7 or 8 years. But NASA seems to have made this decision anyway. And there is a replacement X-ray telescope in the works called Lynx, but that's not going to launch for a few years. And surprisingly, it's going to be of lower resolution than Chandra. Chandra has carried out some amazing work researching everything from black holes to, well, you name it. And it's been the most successful X-ray telescope ever. And its cancellation is going to leave a blind spot, a terrible blind spot in X-ray astronomy. And the astronomers who work on Chandra are also worried about the loss of the community, because there's been a big X-ray astronomy community grow up around the telescope, and they're worried that if Chandra is cancelled, then that community will dissipate, and it'll take a lot to bring it back together again if they ever do. So this is really bad news for X-ray astronomy. It's not fine. This cut isn't final, and I'm sure there's going to be an outcry from astronomers around the world about the loss of Chandra. So we'll have to wait and see what happens. But on the surface, it doesn't look good.
Do you know how much it would cost to keep it flying?
Yes. So basically, if I remember rightly, it was about I think it was around $80 million a year. I think that's all. It was not a huge amount. So, obviously, NASA have to make cuts somewhere because they didn't get the budget to pay for everything. But I hope they reconsider, because this is an important observatory.
I think there is some groups trying to get together and trying to sort of like crowdfund to be able to keep it running for a while, but how long that would last, and it all depends whether or not NASA would let them. Of course, last year we had the Japanese launch a small X-ray telescope, if you remember, called Prism.
That's right.
Prism, and but it's only a small telescope. It's not near.
It doesn't have anywhere near the resolution.
No, exactly. And the next big telescope, X-ray telescope, isn't it Athena?
Yes, Athena,
which is a European.
Yes, that's right.
Thing,
but even that, I don't think has Chandra's resolution. So,
yeah, but that's not due to launch for another 2 or 3 years yet.
That's right. That's right.
I think.
Anyway, moving on, because it's not been a good week for astronomy. There's been another setback this week. The Americans had planned to build 2 observatories in the extra large telescope class, the Magellan telescope and the 30-meter telescope. But now one of them has to go, because the National Science Foundation, which funds this, says America can only afford to build one of these 2 observatories. The combined budget of both of them is $5.2 billion, but the extra large telescope class observatories has been capped at $1.6 billion.
Sure.
So something has to go. And the governing body of the NSF, the National Science Foundation, which is called the NSB, the National Science Board, they've given the foundation until May to choose basically which one will be built and which one will not. The Magellan telescope is a lower risk, but it will have a primary mirror only 40% the size of the European Extra Large Telescope, the world's biggest optical telescope currently under construction in the Atacama Desert in Chile. So this is a bit of a blow, really. The US Congress, on the other hand, has urged the NSF to build both. I wonder if you can guess what's coming next. But what they've done this year, they've cut the funding to the NSF by $800 million.
Oh, my goodness.
Yeah. It was ever thus. I mean, what can you say? This is just a ridiculous situation. So the NSF obviously
invite the US Congress to the Winter Star Party in Florida. That'll get everyone enthusiastic about astronomy.
Absolutely. Oh, that's a great idea.
Perhaps if everybody bought them coffees.
Yeah. Well, they're obviously asleep on the job, aren't they? I mean, for goodness sake. So the NSF has had a massive cut in its budget this year, 800 million. And I thought the US economy was meant to be doing better, but there
The
you
US
are.
economy is doing very well. This is all politics.
Yeah.
I won't go any further. This is all politics.
Yeah, I'm sure you're right, Liv. I'm sure you're right. It's always the same, isn't it? And astronomy suffers. Anyway, perhaps we've got a nice, happy story coming up now. Yes, we have. This could be Ingenuity's replacement. The Ingenuity little helicopter on Mars that recently crashed into the sand dunes and lost its rotors, putting the end to 72 successful flights. Well, this is a proposed, and it's only proposed at the moment, replacement. It's called the Mars Science Helicopter, or MSH, and it's a 6-rotor hexacopter about the size of the Perseverance rover. So quite a bit bigger than Ingenuity.
Very big, yeah.
Yeah, it's huge. And it can carry up to 5 kilograms of scientific instruments. And what they want it to be is a sort of a flying geologist. And it's going to be equipped with lots of geology instruments, spectrometers and the like. And it's seen as the logical next step forward. It's going to, do general geology work, but in particular, it's going to investigate rocks with elevated silica concentrations called felsic rocks. This class contains rocks such as feldspar and silicate. Now, these rocks actually nobody expected to find on Mars. It wasn't so long ago that we thought the whole crust of Mars was basically basalt and that was it. But as we've been finding out over the last few years, it's a lot more nuanced and varied than that. And we really need to know about the Martian crust because it can help us understand not just Mars, but our planet as well, how the crust of our planet formed. So this is quite thrilling. Then we move on to an interesting story about an exoplanet called WASP-12b. And your eyes are not fooling you. This planet is egg-shaped. And we found out recently it's doomed, it will be doomed a lot more sooner than we thought. What's the story with this? Well, it's a gas giant dubbed a superhot Jupiter. It orbits its star at a distance of just 2.1 million miles. And therefore, its year is the length of an Earth day. So it whips around the star in one Earth day. Because of its proximity, the star's gravity is pulling off its atmosphere, and that's why the planet has an egg shape. And we've known for a while that it's going to be swallowed by its star. The planet is reckoned to be only 3 billion years old, and previously the estimate was that it will be swallowed by the star, crash into the star in about 10 million years, but latest estimates indicate it's going to be swallowed by the star in only 3 million years. So it just goes to show you how weird some of these systems are. And the star that the WASP-12b is orbiting is 142 light years from Earth in the constellation of Auriga. So that is one planet we know is definitely doomed in about 3 million years. This is quite an interesting story. Astronomers have found some giant star streams in our galaxy, which may be some of the earliest building blocks of the Milky Way. And the 2 star streams in question have been dubbed Shiva and Shakti. They're thought to have merged with the Milky Way between 12 and 13 billion years ago. So they are very, very early on in the history of our galaxy. And each one of them contains the mass of around 10 million suns. So, quite a substantial amount of mass. And looking at the Milky Way edge on, here's what they look like. You can see Shiva and Shakti there indicated in different colors. So they are, large star streams, and it's surprising they haven't been seen before. Bad news for Odysseus, Intuitive Machines lunar lander. You may remember from a few weeks back, the first commercial lunar lander did manage to land on the moon, but tipped over, unfortunately. It was put to sleep temporarily to hibernate its way through the cold lunar night, but it didn't survive, unfortunately. And mission managers... Sorry?
That's a shame.
Yeah, it's a great shame. They've been trying to contact it, Dave, since the 20th of March, and they've had no reply. So, but it will go down in history as being the first commercial lander on the moon, and that was such a tragedy that it tipped over as it did. But we now know there was quite a complex story behind it. That was not the only failure. In fact, there've been several crises between the Earth and the Moon that the spacecraft managers had to overcome with the aid of their brilliant engineers, which they did.
Yeah.
But the final straw was that it did tip over on landing. So farewell, Odysseus. You are in the history books. So there we are. Sad end to what could have been a really, really successful mission. The mission was not a failure by any means, because they did manage to soft land it on the moon. It did carry out some science. It proved lots of technologies. It was just that last bit that went wrong. And I'm sure Intuitive Machines are going to be bouncing back from this. In fact, I think, Daz, they've already got one for launch in a few months, haven't they?
Yeah, I think it's is it April, May, something like that.
Soon, isn't it?
Yeah, very soon. Because they because I mean, we said before, we've had sort of a glut of these mini landers. Mind you, this isn't a mini lander. This is quite big. I was talking about, waking things up. I wonder if Slim woke up again, and that would have been the third time. Because that was the Japanese one, and of course that was another one that tipped over.
Yes,
because it landed on a slope. It was a lot smaller than the Odysseus.
Yes,
but of course they were all using new technologies. These are proof of concepts.
Yes.
So you can expect things to go wrong, but both Slim and Odysseus did do a soft landing, regardless of how they ended up, because the instrument still worked. So we're getting there. And of course we need this precision landing for when we send the Artemis astronauts to the South Pole, because of course this is all happening in the South Pole, which is very, very rough. It's just craters everywhere, and you need to be precise. So we're getting there, and we've got a few more of these to come this year.
Yes,
So,
IM2 and IM3 are already in development. And,
indeed. So this is good news. And viewers, if you'd like to know more about why all of this effort is being expended to land at the South Pole of the Moon, well, we have a video about it on our channel. It's called Race to the Lunar South Pole, and that gives you a lot of information about this current interest in the South Pole of the Moon and exactly why countries are desperate to land there. Now, astronomers have found a new haul of giant galaxy superclusters. There's been some amazing work done recently, and believe it or not, they've discovered 662 new galaxy superclusters. And the most notable of these is called Enasto, named after, I believe, Portuguese astronomer who did a lot of work about the structure of the universe. And it's been dubbed the Enasto supercluster. You can see it inset in the picture there. And it's 3 billion light years from the Earth, and it contains the mass of 26 quadrillion suns, and that's 26 followed by 15 zero suns. So again, a big discovery. It's 360 million light years across in total. Not sure the total number of galaxies, but that's a lot of stars. And these observations were made by the Tartu Observatory in Sweden. So this is a fantastic new discovery. I just, again, wonder why we haven't seen this before. I wonder what techniques they use to find this, because something that size, it's surprising that it hasn't been seen before. Anyway, it hasn't, so this is a fantastic new discovery. Moving on to asteroid Bennu, the sample that was returned from this asteroid. The initial analysis of it has come up with some interesting things. The sample contains a surprising amount of magnesium phosphate in the form of little white crystals, and these are extremely unusual in asteroids. So there's a lot of investigation to be done of those, but also the sample contains the widespread presence of glycine, which is the simplest amino acid, so a building block of life. and a crucial ingredient of proteins, as well as other water-bearing minerals, including carbonates, sulfites, olivine, and magnetite. Now, what all this is evidence that Bennu was involved in several water-related episodes in the distant past, in the early history of the solar system. Whether it was part of a water world in the early solar system that no longer exists, we don't know. But this sample is just screaming out water. So in the distant past, asteroid Bennu was heavily involved in some way with water. So this is an amazing finding. There are abundant water-altered compounds called phyllosilicates, as well as a rich collection of other organic and hydrated minerals. And these phyllosilicates are structurally bound to water in meteorites. We find them in meteorites. And, again, could help to answer the question of where Earth's water came from. Was it delivered to Earth in asteroids and meteorites? So, there's an estimated, I think that one scientist said they could have 10 years studying this sample from Bennu, slowly teasing out its secrets and revealing to us the early history of the solar system. And it's all very, very exciting. So let's keep you up to date with that, as I'm sure we will, as they reveal more discoveries about this sample from asteroid Bennu. Now, Betelgeuse is acting up again. You may remember the so-called Great Dimming episode of 1919-1920, where Betelgeuse got significantly dimmer and noticeably dimmer in the night sky. Well, it's happening again. It's faded by 0.5 magnitudes since late January. And astronomers don't know if this is the beginning of another great dimming episode, how long it will last, how dim it will get. We just don't know. The great dimming episode is now believed to have been caused by the star throwing off a huge amount of mass, which coalesced as dust and blocked out the light of the star, hence its dimming. As you probably know, if you know anything about Betelgeuse, it's due to go supernova sometime within the next 100,000 years, so don't wait up. Some studies, however, say it may be much sooner. The internet is full of clickbait videos saying it's going to happen next week. Ignore those, it's not. So we'll have to wait and see what happens with this latest episode from Betelgeuse. Now, this is the Vera Rubin telescope in Chile. The Vera Rubin telescope, I have to try and put my teeth in, had an important event this week. The telescope is under construction. It's a large-scale survey telescope, and it's going to carry out important survey work in an unprecedented way that we've never had before. And as you can see in this picture, you see the trucks in the foreground. They are towing a mirror up the slope towards the observatory. And in fact, it's the primary tertiary mirror, because it's the design of the telescope is such that the primary and the tertiary mirror are one unit, and it's been moved inside the astronomy building for the very first time, ready to be polished. It's an 8.4 meter telescope, and it's just a glass blank at the moment. It's been in storage since 2019 when it arrived, and it was going to be coated within the next few weeks. The observatory is expected to see first light later this year, but the full science observations are not going to start until August 2025. It's going to image the entire southern sky every 3 days using the biggest digital camera ever built, having a resolution of 3.2 gigapixels. And if you want to know what a 3.2 gigapixel digital camera looks like, well, it looks something like that. So you can see the size of this camera. It's absolutely enormous. It's got an incredibly wide field of view. In fact, if you look at this model of the collector on the telescope, it's a full-scale model. That's the size of the full moon. So you can see it's got an amazing wide field of view. Now, the telescope is going to carry out, as I said, survey work. It's looking for things that change in the night sky. So supernovae, asteroids moving, anything that changes by repeatedly photographing the sky. The total southern sky every 3 days, as I said, it's going to generate lots and lots of data about things in the universe that are changing and evolving. And nothing like this has ever been done on this scale before. So we're looking forward to first light from the Vera Rubin telescope. Now, study of Europa has come up with the interesting fact that Europa produces enough oxygen to keep 1 million people alive for a day. That's today's interesting fact. It produces about 1,000 tons of oxygen from its thin atmosphere every day. But here's the rub. This is a lot less than had been thought. In fact, up to 86 times less oxygen than was originally thought. But Juno, the wonderful spacecraft that's been studying Jupiter for years now, has done a study of the atmosphere of Europa. And this smaller amount of oxygen has implications for the possible existence of life in Europa's underground ocean. Don't forget that Europa has more water inside it than all of Earth's oceans combined. So this global underground ocean has, attracted the attention of planetary scientists and astrobiologists because it's conceivable that there could be life down there under maybe up to 20 miles of ice. Now, the way that this works is that there's hydrogen in the atmosphere of Europa, charged particles from Jupiter, and they're very energetic. They split the hydrogen and oxygen, and the hydrogen escapes into space, and the oxygen molecules they fall down onto the surface. Now, the question is, does any of that oxygen actually penetrate through the ice to the ocean below? And this is the big question. If there's not as much oxygen as scientists thought, then perhaps there's not enough oxygen entering the ocean for life to exist, assuming that the life in the ocean needs oxygen. So this is a big question at the moment. Lou, have you got any thoughts about this?
Well, there are two ways to get constituents into the ocean. One is from the top and one is from the bottom.
True.
So if there's the oceans are liquid because there's a tremendous amount of tidal friction, and so there should be some outgassing of the planet at the ocean's ocean floor of unknown composition.
Yeah.
The other way is to have impactors strong enough to penetrate the thick ice. So we don't know.
We don't know. Well, we should find out with the Europa Clipper, shouldn't we? We'll get some.
Hopefully.
Find out some more answers at least. So there we are. And lastly this evening, I just have to share this beautiful picture with you of this Martian dust storm taken from orbit by the Chinese space probe Tianwen-1, which is orbiting Mars. And I think this is an absolutely stunning image. I'm sure you'll agree. And don't forget that this is happening in an atmosphere that's only 1,000th the pressure of Earth's atmosphere. So even though there's a lot of dust, you wouldn't feel very much in the way of wind. So there you are. I just had to share that because that's my favorite image so far this week. I think it's absolutely beautiful. So there we are.
Yeah.
So there we are. So that brings us to the end of the news for this week.
What I was just going to say, Andy, is that these dust storms, sometimes they could actually become planet-wide.
Oh, yes, they are.
And I can remember a few years back, we were trying to get some images of Mars, and virtually for the whole of the season, Mars was at its best. You couldn't see a thing. It was totally blanket.
No, that's right.
So, and as you said, the winds are not 100-mile-an-hour winds or anything like that. No. So, Matt Damien, you're telling porkies.
Andy Weir's telling porkies.
Well, yeah. Yeah. He was just aiding and abetting. So these, and they can last for a long time. And of course, they're a nightmare for the little rovers and the robots.
Yeah.
Because they basically have to be shut down. And then they just got to sit there and hope that there's enough wind there to actually carry the dust off of their solar panels. Because I mean, which one do we lose? Not Percy.
No, it was Spirit, wasn't it?
Oppie. Was it Oppie? We also lost Oppie. Opportunity? Or was that
both of them eventually lost to Sand.
Yeah. Because Oppie went to sleep for the winter and they couldn't wake it up again.
Bit like you, Dan.
So yeah, hibernates. But it was a sad state of affairs. They were trying to get people to send in postcards saying "wake up," giving an alarm call and stuff like that. I was sad enough. I sent one. But so
by the way, Andy Weir, in defence of that episode in the book and the film The Martian, where there was the dust storm with the severe winds we know could never exist on Mars. In his defence, he said he knows that, but it was the only way he could think of having to make the astronauts leave the planet very quickly.
Make the story.
So it's the only reason he could come up with. So we'll allow him that, because the rest of the book was brilliantly scientific.
Could have had a meteorite strike.
Yeah, I suppose. Anyway, there we are. So that's the news. Hope you enjoyed that, viewers. And nice to see Ian's in now. So hello, Ian. Hope you're well. Kenneth's in. Hello, Kenneth. Hope you're doing well. What we're going to do now is go over to Dave, and Dave's going to tell us all about the Florida Winter Star Party, I hope. So there you are, Dave. All yours. The floor is yours.
Hi, everybody. I hope you can hear me okay as I go along.
You sound fine at the moment, Dave. You're fine.
Sound is good. Okay, fantastic. My connection at this end is a little bit wonky. I'm sorry. So welcome, everybody, to the presentation on the Winter Star Party 2024. It was the 40th anniversary of the Winter Star Party, so it was very well attended. I'm going to, as I go through these slides, if you have any questions you want to ask, just put them in the chat and I'll answer them as we're going along. And again, panel members, if you have any questions, just bowl straight in with the question and I'll answer as you ask.
Thanks, Dave. We will.
So, got this bunch of slides for you. So the first slide is, what is the Winter Star Party? And then we'll have a look at the journey that I took to get to the Florida Keys in South Florida. Then we'll go through the location and the sky conditions at the Winter Star Party. Winter Star Party is very famous for its people. So there's a slide on some of the people that I met there. Then, of course, you've got the equipment that people take. It's very substantial. And they run an events program as well. So we'll look at the events that are going on. And then the final slide is what NPay was getting up to at the Winter Star Party. So the Winter Star Party is one of the UK's most popular star parties. It's been going a long time, celebrated its 40th anniversary this year, and it is famous for its high quality guests. For example, John Dobson, the inventor of the Dobsonian telescope, was there in 1996. And if you look up John Dobson Winter Star Party on YouTube, you can actually find the presentations and lectures that he gave there in 1996. Additionally, it is the most southern viewpoint of the continental USA. So it's a unique opportunity for Americans to see part of the southern sky without actually leaving the country. So that in itself makes it a popular venue for a star party, and one of the reasons why it's been going for so long. Just changing slides here. It's not up yet.
No, it is here.
Is it up on your screen?
Yeah.
Okay, fantastic. It's not up on mine. Oh, here we go. Yeah. It's turned up. So the journey to the Florida Keys and the location of the Winter Star Party, it's actually at a scout camp on the far tip of the Florida Keys, and it's a long way from most places, not least of all Nottingham, where I'm based. So I journeyed from Nottingham to London to Miami, then to the Florida Keys, and then to Camp Sawyer, the scout camp where it is held. So I flew out of Heathrow Airport, which is obviously London's main airport, and I discovered a little bit of a travel hack here, which I can share with you. So if you're a solo traveller going to Heathrow and you live north of London, if you get a National Express coach to Golders Green, you can then take the London Transport Network to Heathrow, and your trip from wherever you are, Manchester, Liverpool, Nottingham, to Golders Green will cost you only between £5 and £10 one way. So that's quite a good travel hack, I thought, especially given the cost of rail transport in the UK for solo travellers. Obviously, if you're going as a group, that's not so relevant.
Yeah. I used to get the Heathrow Express from Paddington. And I don't know how much it is now. Last time I did it was about 20 years ago, and it was £16 then. So God knows what it is now. So did you have a pleasant journey then, Dave? Did you have a pleasant journey? Was it all okay?
It was very nice. I flew on American Airlines about that time of year to visit Miami, where I flew into. It's the quietest time of year. So the whole of the back of the plane where I was sat, as you can see from the photo from the second left, the plane was completely empty.
Wow.
We flew along sort of the eastern seaboard of the United States, and there was quite a nice view of New York out the right side of the airplane, but it didn't really photograph very well. It was a bit too distant, if you see what I mean. But you could make out sort of like Manhattan and Long Island and that sort of stuff. So that was quite interesting.
What was the in-flight film?
So then I stayed overnight in Miami and took the Greyhound down to the Florida Keys. So another travel hack for you, if you, again, solo travel and you go on the Greyhound, if you ask them nicely, they'll actually drop you off at the stop closest to where you want to be. You don't actually have to go all the way into the main terminus in the cities.
Oh, right.
Oh, sweet.
Yeah.
So they dropped me off outside Camp Sawyer, and this is the location and the sky. So it's the black arrow is indicating where Camp Sawyer is. It's 32 miles to Key West, which is a small town and the biggest place in the Keys. It's got its own airport. You can fly into Key West if you want, but you've obviously got to mix and match your flights to arrange that.
Yeah.
It's 65 miles to Key Largo, which is the first island in the island chain of the Florida Keys, and it's 132 miles to Miami. As I already said, it's the southernmost location of the United States, and it is a beachfront property. So pretty much everywhere you go, until you get to Big Pine Key and to Key West, on one side you've got the Gulf of Mexico, and on the other side you've got the Florida Straits. So it's quite a cool sort of geography going on in that respect, where you've got two large bodies of water meeting.
Wow, it looks beautiful, Dave.
No, I mean, as you can see from the pictures, it's very pretty. The picture on the top left, the glamping tents that you can stay in. That was the one that I stayed in. And there's the picture on the top right is a 7-mile bridge, and that was like a resort, restaurant, hotel that we stopped at for some food on the way back. This was one of the birds that I photographed. They were quite tame, sort of running around everywhere. And then a bigger map of where Miami and the Florida Keys fit together at the tip of Florida.
Dave, would it be an advantageous place to actually watch a Starship launch?
Where is Cape Canaveral?
It's not Cape Canaveral. It's Boa Chica.
No, nowhere near.
Yeah. Well, it's got to fly over the tip of Florida, hasn't it?
Oh, that's true. That's
So I
true.
was just wondering whether or not it'd be a nice place to possibly. Well, it'll be quite high by the time it gets there, but it would whether it'd be a chance to see if it flew over. I'll investigate that. I'll investigate.
Yeah,
I
that.
no,
don't think
it sounds good. I mean, I don't know the answer to that question. I'm sorry, but I
Yeah.
mean, if you can see it, it would be a great place to see it. It's just a great place to observe.
Yeah.
The sky condition. Oops, go and say again.
No, I was going to say, Daz, I don't think you'd see the actual launch, but you probably would see it come over, definitely.
Oh yeah, not the launch. That's what
Yeah.
I meant. It's and if they did a night flight, that'd be brilliant.
Yeah, absolutely. Yeah.
Yeah, I mean, you'd see a night flight if it was going overhead, definitely, and that'd be pretty impressive, I'm sure.
Yeah.
The sky is pretty dark. It's a Bortle sort of like 3-4, depending on how you count it. So it's a lot better than sort of the urban skies that would be used to, but it's not the best quality sky, if you see what I mean. But
No.
All intents and purposes, it's pretty reasonable, and it's certainly better than most of the skies that I have access to on a regular basis. So there was a definite improvement in sky quality for myself, for my typical observing.
Right.
So then the next slide is the people. So the Winter Star Party is famous for the people who attend, and this year was no different. So we had Scott Roberts and Kent from Explore Scientific, and there in the bottom left picture, we were doing a live stream of an exposure with some equipment that Scott Roberts and Kent were testing and marketing whilst they were at the Winter Star Party. Then we also had Mike Lockwood from Lockwood Custom Optics, which is a mirror manufacturer. He is stood next to his electronically assisted EEA. I've got that. And so he'd got like a 12 Dobsonian type mount, but it was going into a night vision eyepiece. So that was extremely interesting to look through. It was, I was getting quite into like the night vision stuff actually when I was there, because a few other people had different things, but yeah, he had the biggest night vision telescope, maybe ever, I'm not sure. Then there was Mark Radis from the Refreshing Views YouTube channel. So that was good to hang out with him. And then Trevor Jones from Astro Backyard. So not really needing much introduction. There with his partner in front of some rigs that they'd got set up, and they were trying stuff out. And then there was Marcus Ludes from APM Telescopes in Germany. So what was nice was, because it was like a whole week event, everyone's just like hanging around with each other, and there's sort of like about 200 or so people at the event, and we're all like having breakfast together and like sharing hot chocolate at 2 o'clock in the morning and that sort of thing as we're looking at things. So it was a really, really cool sort of vibe to it. And as you can see, you've got the sea behind you, so you are bang on the beachfront.
Wow.
Then next slide is the equipment. So the equipment that's available is shockingly good. Now, that's not that the people who organize it put on the equipment. It's the equipment that the other astronomers bring. So everyone's sort of like set up and they're doing their own observations, and say you've got people come down there especially for the southern sky views. So if you're someone like myself with a front the size of Blackpool, who's quite happy to just like bowl in and start chatting to strangers and ask them for a look through their telescope, that worked quite well. So I did get to look through a lot of equipment that I wouldn't ordinarily get to use. So sort of from the top left, we've got this Starfield Herschel wedge that was doing some solar observations through. So I had a look through that. That was pretty cool. Got some nice photos just on my smartphone through the eyepiece. Then
We appear to have
binoculars on parallelogram mount. That was good. Then another one of the organisers is a lawyer in Miami, and this is a telescope engineering, I think 160 APO extra mount. That's about $50,000 worth of telescope there. So that was nice to look through. And the guy who owned it again was very generous. There's always a big queue of people through.
Gosh.
Out. Then bottom left, we've got, I think that's a Williams Optics astrophotography rig with a guide scope on top of it. Then in the middle at the bottom, this is a custom built planetary equatorial that one of the people built, and it was a nice assembly, and I was chatting to him as he was putting it together. I didn't actually get to look through that, unfortunately, but it's
huge. That's huge.
Yeah.
That's nice of that.
And then bottom right was a very nice Dobsonian with custom built wooden box that the guy who owned it was very proud of, and spent lots of time telling us about how we'd acquired that telescope and the wooden design and such. And it was an amazing view through it. You could see the spiral arms on the Whirlpool Galaxy and everything with the naked eye, which was very impressive.
Wow. What a fantastic kit.
Yeah. I mean, and that's just some of it. I mean, the RVs and the cars and such, the motorhomes and that people had were spectacular, to be quite honest.
Yeah.
I'm just not into RVs and motorhomes. So.
Wow, look at that.
Now, they also put on an event schedule. So let me go to the next slide. Is that loaded?
You've gone one too far, Dave. You need to go back one.
One too far? Oh, dear.
There we
go.
That's it.
So there's a lot of stuff going on. I mean, it's a total immersion, 24/7 astronomy experience. It's almost a shame that you got to sleep, to be honest. But so it starts. The food service sort of opens up at about 8 o'clock in the morning and runs through until about 4 in the morning. So there's always food available and drinks and such to get. And usually sort of started with breakfast in the tents. And there was like a daily swap meet where if you wanted to exchange any equipment with anyone else for equipment of equal value, you could do so. There was also a talks schedule put on where different speakers from different disciplines of astronomy would be giving their talks. I didn't get to go to all of them because I was in the vendor tent most of the time, but I did go to the introduction to celestial navigation, which I found very interesting, and learning how to do astronomy and navigation the old way, so to speak. Then there was the vendor tent. So NPay was there with the NPay stand, and there was 3 or 4 other people from the States also vending different equipment there, and Scott Roberts with Explore Scientific, of course, they had a vendor stand. There's an amazing number of opportunities to get involved in different observations. As I say, it does benefit sort of the outgoing person who's happy to like go up to the different groups of people who are there and sort of like break through any internal group dynamics that are going on. So definitely, if you're an outgoing person, it would definitely suit you. The other good about it is, of course, you are in the Florida Keys, so there's a whole load of other stuff you can do as well. You can go like beachcombing, you can go scuba diving, you can go fishing, you can go boating, you can go to visit Key West, which has got its own unique thing going on. So it's really worth, maybe taking an extra week and making it a fortnight's holiday, especially if you're traveling with a partner, to do the astronomy and then do the Florida Keys stuff as well. The only unfortunate thing is, whilst Miami is in its off-peak season, the Florida Keys is in its peak season. So it's the busiest, most expensive time of year in the Florida Keys. So it's potentially possible to run up quite a substantial hotel bill if you're not careful. So maybe watch out for that. But otherwise, shoot the lights out.
Yeah, absolutely. Gosh, it all looks so interesting, Dave. I could quite happily spend a week there. Yeah.
Then finally, NPay at the Winter Star Party. So we were the only foreign non-American vendor there, and we were showcasing our new 2024 product lineup. You can see all 7 of them on the table here. So on the middle photo, starting at the bottom right, got the 2-inch flip mirror diagonal. Then in the middle, we've got the telescope back. On the left-hand side, we've got the ruby turret. Above that is the new 2-inch turret. On the right-hand side of that is we are now the world's only manufacturer of a flip turret. So basically, it's the flip mirror and the turret combined. So you've got your 6 eyepieces, which you can rotate in between. And then you might see this black lever here. You flip this lever and it opens up the port at the back for you to do astrophotography through. And then at the top, we've got the astro imaging filter changer and the Thea 90 collimating star diagonal. So they were all very popular with people at the Winter Star Party, and it was great to show them. And that is the end of the presentation. So thank you very much for allowing me.
Thank you, Dave. I mean, that's just absolutely brilliant.
I did wonder when you were going through that picture that's actually on the screen now, it's just gone past. There's an Airstream caravan there, and I was wondering whether that was Scott's Airstreamer. So yeah, Scott Roberts. So obviously you said he was there, so that could have been his.
Yeah,
he's got a passion for them.
Indeed.
Yeah.
So there we are. Well, thanks very much for that, Dave. So glad you had a great time. Is it something you plan to go back to next year?
Maybe not next year. It's all got to be. We've got to count our United States trips, if you see what I mean. So I think maybe an alternate one with the Northeast Astro Fair.
Yeah. Okay. Well, very best of luck with that.
Yeah, very well. Thanks for that.
Thanks for coming to tell us about it.
It's a lovely place, if not.
It's beautiful, isn't it?
I did have a look on the Google Maps and all that, and Boca Chica is just slightly, it's opposite, but just slightly north. So it would be on the flight path if it's going across the Gulf of Mexico. So yeah, it could be a place if they start doing night launches.
I'd like to get closer if I could, though.
Oh yeah.
Definitely.
Yeah, sitting on one of those towers with your legs dangling over, right next to one of those tanks. Yeah,
that's right. All right, moving on. Thank you to those of you who have scanned the QR codes tonight. I can see a few people have, so thank you very much for your support this evening, as ever, much appreciated. And Ian's joined us. Hope you're okay, Ian. Kenneth's here. Hi, Kenneth. Hope you're well too. Thank you for being here. What we're going to do now, apparently, and I don't know whether you know this, there's a total eclipse of the sun coming up next month.
Is there?
But yeah, there is. Unbelievable. I don't know how it is. I think it may be in the United States, but I'm not sure. I know a man who does know, though, and that's Lou, and he's now going to tell us all about it.
Yeah, who knew? Solar eclipse. Well, it turns out you're guaranteed to have at least 2 every year, but not always where you'd like them to be. So we are fortunate here in the U.S. I'll show you some maps in a moment that we've had 3 solar eclipses, 2 totals, 1 annular, just in the last 7 years or so, crossing the continental U.S. So kind of a bounty of eclipses, which will end, at least for a while, unfortunately, on April 8th. So we have some eclipse watching to do. Now, just to remind everyone, it takes a while to flip these slides apparently. So total solar eclipse, here we are. Our moon uniquely covering the sun. This is the only place in the solar system that we know of that a planetary moon is the same, or roughly the same angular diameter as the sun. So occasionally we have this opportunity to not only view the solar atmosphere, the corona, as you see, but get some information on the sun's magnetic field. As you see the plasmas here coming off in various directions, they are mimicking the solar dipole magnetic field. And it's a unique opportunity to view very close to the photosphere, the chromosphere, which we can't do even with telescopes that have masks. They tend to block out much more of the photosphere than that. So if we want to understand and explore processes very near the surface of the sun, what we call the photosphere, solar eclipses appear to be the way to do it. Sorry for this lag. It looks like it takes a few seconds to flip the slide, so I'll have to anticipate. So we would have solar eclipses every month, of course, and except that our moon, rather uniquely actually, is orbiting almost but not quite in the plane of the Earth's orbit, in the plane of the ecliptic. It is tilted by about 5 degrees, its orbit, with respect to the ecliptic. And this, it turns out, is consistent with the information that we have regarding the origin of the moon and the angular momentum that the Earth and the moon share, and the moon's orbit relative to the Earth. So this is the situation, and only when the moon passes through the ecliptic, either as what we call an ascending node or a descending node, this line of nodes that is the intersection of these two planes, will you have a solar eclipse. So I'm just refreshing everyone. Here's the geometry of a solar eclipse, where the umbra, the two parts of the moon's shadow, are projected onto the Earth, the dark umbral part of the shadow, and then the lighter penumbral part of the shadow. If you are in the region of the very relatively thin umbral shadow, you will see a total eclipse with the sun's photosphere completely blocked. If you are in the region of the penumbral shadow, you will see a partial eclipse. Oh, by the way, thanks to Fred Espinette for providing some of these graphics. You'll see his name, Mr. Eclipse, we call him. And in fact, Mr. Eclipse, he calls himself. So you'll see that on some of the graphics. So we have two situations here. We have the moon at apogee and the moon at perigee. The moon's orbit is elliptical, as all orbits are. And this is just an example. We don't usually think about it, right? But the size of the moon, the apparent size, the angular size of the moon as we see it from the surface of the Earth actually does change quite a bit, depending upon whether the moon is far from the Earth in its orbit or close. And this also has an impact on what kind of solar eclipse we are likely to have. If the moon is at apogee, in other words, it's close to its furthest point in its orbit, then it does not appear large enough to cover the whole sun. And you actually have what's called an annular eclipse, where the moon may move directly in front of the sun, but there's still a ring, what we call a ring of fire around the sun, the part of the sun's disk that is not covered. And that's what this looks like, an annular eclipse. Now, moving on to the real point of all of this, we're going to have a total solar eclipse that crosses the United States and Mexico and some of Canada on April 8th of this year. It's a Monday. In fact, I've got to finish my travel plans for this today. The path of totality is roughly 150 miles wide. And it turns out that because this eclipse occurs when the moon is near its perigee, near its closest point to the Earth, not only is the length of time of totality increased, it'll be about 4.5 minutes at its maximum, but the width of the path of totality is larger. So here we have about 150 mile swath width of path of totality coming in from the west coast of Mexico, right around Puerto Vallarta, coming up through Texas and a number of other states, including the southernmost point of Illinois, which is where I will be at Southern Illinois University. We'll talk more about that in a few minutes. And then up through Pennsylvania, New York, New England, and off into Canada. Let's see.
I'm going to be in Akron, Ohio.
Oh, great! You're coming over to the States. Fantastic.
Yeah,
fantastic. At least I think it's
super
fantastic.
Psyched about it.
I'll show you the. I'll show you the estimates for cloud cover in a minute. You may not be as excited at that point, but
and it's 50, isn't it?
So I mentioned that within a 7-year span, we had 2 total solar eclipses. Here you see the path of the 24 eclipse as well as the path of the 2017 eclipse, and they intersect right there in Carbondale, Illinois. Now, it turns out there's another town rather near Carbondale called Paducah, and they have a little bit of a competition going as to which town is, in fact, the crossroads of these 2 eclipses. So I think there's a little rivalry there. And in fact, I think we were being interviewed by some of the Paducah news media, and as I understand it, it got a little bit territorial. But you know, such is the nature of eclipses. So that's 2 eclipses crossing the U.S. But wait, there's more. Back this past October, there was an annular solar eclipse stretched from roughly Oregon to Texas, and I was in Albuquerque, New Mexico for that, and I'll show you some pictures of that later. So quite a wealth of eclipses. I mean, who gets this lucky within a span of 7 years? We do.
Yeah. Forgive me if I contain my excitement.
I'll forgive you. I'll forgive you, Andy. So, chances for cloud cover. As a just kind of first order rule of thumb, the further south you are, the better chances for clear skies you have. As you move up along the path, the chances get a bit worse. Where I will be in Southern Illinois, it's about 50-50. So we're hoping we're going to have a big group from NASA Goddard, JHU Applied Physics Laboratory, NASA Edge, Adler Planetarium. We're all going to be there streaming the eclipse. And even if it's cloudy, we have about 100 telescopes lined up along the path from Texas through Maine, which will be showing visible H-alpha and calcium K images. So I'll show you how to access that in a few moments. There we go. Okay, so whoops, it's a little laggy. These,
yeah.
There we go. Okay. So this is showing, of course, if you're on the path of totality, you see a total eclipse. But if you are off the path, this shows the lines of percentages of the sun's disk that will be covered. Where I am, in near Washington, D.C., just a little north of Washington, D.C., there'll be about a 90% coverage of the sun, which sounds great, right? 90%. But for those of you who have seen a total solar eclipse, you know that the difference between even 99% coverage and 100% coverage is, in fact, the difference between night and day. Being able to see the sun completely blocked out, the light around you just plummeting, and the solar corona coming out, the only time you can see that in nature, is an amazing event. People cry, people laugh, people sing, you hear camera shutters everywhere. And if that wasn't enough, hotels triple their rates. So all kinds of things happen during a total solar eclipse. And that's why we're going to be on the path. Party in the path, as we say. Well, for Mexico and the rest of North America, here are some times where you can see the duration of totality. Maximum duration, I think, is in a place called, two places, okay. Nazos, Durango, these are in Mexico, and I can't even pronounce it, Coazuela, in Mexico. But realizing that maximum totality theoretically for any eclipse is 7.5 minutes, and anything above 7 minutes is extremely rare. This eclipse, with a totality of greater than 4 minutes in most places along the path, is twice the length of the one in 2017. So this will be a real opportunity to take some good images of the eclipsed sun.
Luke, can I just ask you about that? Can you just go stay on that slide? Is this a mistake? The 4 places listed for Ohio in the right-hand column, top of the right-hand column.
Okay.
In Toledo, it's only 1 minute 54 seconds, but the other places in Ohio are 2 and 3 minutes.
Yes, I think that's accurate, and that's because these towns are not smack dab on the center line.
Right.
Right. So
right.
the further out you move from the center line, the
Ohio must be bigger than I thought.
Ohio's big. Here's Kevin Earp says he'll be north of Austin, Texas. Great place to view. Texas has great chances.
Fantastic. Oh, well done, Kev. God. Hope you have a great time, obviously.
Yeah, we want some gallery pictures.
Yeah, absolutely.
You're going to be flooded with gallery pictures.
Oh, we are, aren't we? It's inevitable. Yep.
So enough about me. Let's talk about you. This is a global picture of the path of totality and the various increments away from the path. And you'll see that some of the UK is just barely in there.
Yeah.
To see
Ireland, yeah.
part of the eclipse. So let's explore that a little bit.
Oh, right. Goes a bit further east. Birmingham.
Oh, you see these before I do.
Yeah.
Yeah, I just saw that just popped up on my screen right now. So.
Yeah, definitely. It's the lagging, I don't think, is at this end.
It's at my end.
Yeah.
So here's the UK, and here are those same percentages of solar coverage that we saw in the larger graph. And I looked up the times for start and end of partiality in Scotland, England, Northern Ireland, and Wales. So, it's not a lot, but sometimes you have to take what you can get. And if you have clear skies, you will see a partial solar eclipse.
That's worth knowing.
That's actually quite a way east, isn't it, considering?
Yeah.
Mm-hmm.
I was just wondering around
impressive.
about down by the Canary Islands, because it seemed to stretch down that far. And you'll be more out in the Atlantic there as well. So
Perhaps,
interesting.
but not in totality.
No.
Luke, do you mind just going back to the previous slide for a moment?
Sure.
Thanks.
That's it.
Oh no.
No.
We need to catch the edge of it, don't we?
Damn, it's not going to get as far as Spain. Never mind.
Hey, you've got 2 coming up soon.
Your time will come.
I know. I'm
Yeah,
just impatient.
2027. It's all about Spain.
2026 and 2027 too.
Yeah. Well, in fact, the 2027, 2027, the best place to see that is going to be Algeria.
Yes, indeed. But the 2026 one, the path of totality is just 3 hours from here on the train. So,
wow. Well,
however, and Susan, my wife and I have talked about going. It's going to be in August in Spain. What's the temperature there? About 70, 80 centigrade, something like that?
No, nowhere near. No, it's. I would say, depending on the year.
Fahrenheit.
It could be. I would say between 35 and 45 C.
Okay, so 40, double that. That's 80. Add 32. So 110. Okay, yeah. So it's going to be pretty hot.
Oh yeah, it's always hot. But it depends so much on the year. We have variable years, so who knows?
Well, I'll just note that Greenland and Iceland, at least the west coast of Iceland, Reykjavik, are in the path for 26.
So, yeah.
Okay. So what is in store? As we have just been saying, there is a total eclipse, is the blue line here at the top, coming down right through Spain on August 12th of 2026.
That's the one.
There's another, let me see. Actually, I'm going to move it to my big screen here.
There were 2 blue lines going over Spain. It's the southern one. That's the 2027 one.
Okay. There we go. Now I can see a little better.
Yeah.
And just a whole variety of other eclipses, as I said. Now, these are total and annular eclipses. These do not include partial eclipses.
Indeed.
But you are guaranteed in the plus or minus 18 degrees from these nodes, these ascending and descending nodes, to have at least 2 solar eclipses somewhere on Earth every year. So you just have to be in the right place. Look at these in Antarctica. Don't you want to go there? After going to Spain in August, I think I'd like to go to Antarctica. That would be a good place.
That would be good.
Yeah. So it's not too late to make your travel plans for Spain right now. Don't wait till all the hotels are booked.
I was thinking about doing that very thing very soon, actually booking a hotel.
Good luck with that one.
Yeah. Well, we'll see. You can only try.
Yeah, you can only try.
I've been to, at least in my adult years, where I wanted to do photography and so on, I've been to 3 eclipses. One was in France in '99. That was a bust. I was standing out. I have pictures of me standing outside in just north of Paris with umbrellas over my telescopes as it was raining. But the rain stopped, and I was able to take pictures of the eclipse at times using the clouds as my solar filter. Don't try this. Don't try this at home. Not a good idea. And of course, for totality, it was clouded out, and this totality is not bright enough to see anything. So we just.
You say you were north of Paris?
Yes.
What was the light pollution like?
Not bad. No, we were in Soissons. We were quite a bit north.
I was being flippant there.
Oh, I see.
Now these are decent pictures. Good job.
Yeah, where are they?
In Carbondale, the 2017 eclipse worked for us. We got about 10 seconds of totality between the clouds, but that's enough. And then in Albuquerque this past October, we saw an annular eclipse, and I snapped these pictures of the progression of the eclipse. So they're quite easy to photograph, and they're a lot of fun. And for many people, they're kind of a spiritual experience watching the sun get plastered by the moon. Here we go. So eclipse safety. The safest way to watch an eclipse is online, okay?
Mm-hmm.
But if you're going to try to grab those photons meant just for you, you might want to have some eclipse glasses. Now, you need to be a little careful with these. There is an ISO standard. It's called ISO 12321-2 that if the glasses meet that standard, they are safe in the visible, the ultraviolet, and the infrared, and they're safe for your eyes. In 2017, NASA found out that there were glasses, mostly from Asia, that had that stamped on them, the ISO certification stamped on them, and they were not ISO certified. So you want to make sure you get glasses from a distributor that you know and trust. If you're not going to do that, another great way to view an eclipse is with a camera obscura, basically a pinhole camera. Even a spaghetti colander is a great way to view an eclipse. Just hold the spaghetti colander up to the sun. Each of the little holes is its own pinhole camera, and you will see an image of the eclipse sun down on the sidewalk or piece of paper. The American Astronomical Society and NASA and other groups, as well as ophthalmological agencies, have put together a safety document for how to safely view the eclipse. And this is easy to find if you look at eclipse safety and AAS. If you just Google that, you'll find more information. And this is my favorite eclipse quote. I had to throw this up. This is from, my goodness, 2,000 years ago, over 2,000 years ago. Nothing can be sworn impossible since Zeus made night during midday, hiding the light of the shining sun. So this is like the event of all events. Everybody who is anybody will be on the path of totality.
Fantastic.
Fantastic. Yeah, brilliant.
I'll just close with this. This is the Southern Illinois.
Oh, sorry.
Sorry.
Right, put it back in.
There we go. This is the Southern Illinois University webpage, eclipse.siu.edu, where we will be interviewing NASA scientists and interviewing eclipse specialists and technology specialists. We'll have images from all along the path. NASA Edge will be there streaming the eclipse. Adler Planetarium will be there. And we understand, I just talked with Bob Baer at SIU this morning, who is part of my team here. There are 90 news media that have signed up to come to SIU to do interviews and to stream and broadcast the eclipse. So it's going to be quite an event.
Quite busy.
Very busy. Right. Thanks a lot for that, Lou. Obviously, we would like to wish you and Dave and Kev a fantastic eclipse, and make sure you send your images in to spaceoditieslive@gmail.com so that we can put them in the gallery. So there we are. All right. Now, just to finish off today, you may be aware that there was quite a ferocious solar storm a few days ago, but it didn't produce many aurorae. And lots of people have been scratching their heads saying, well, the strength of that storm, the strength of that mass ejection from the sun, it should have produced really strong aurorae, but it didn't. So Daz is now going to tell us why exactly that didn't happen. Aren't you, Daz?
Well, I'm going to try and explain it. It was a bit of it was a disappointment for a lot of people There was some aurora, but nothing like we were expecting. I mean, first of all, we saw. Oh, hang on, sorry, I've got the wrong one. There was a. Let me just flick through these because I've got to get to the alert. What we saw on Saturday, we all knew this was coming. What we saw on Saturday, just before between 3 and 4 o'clock, we got, well, even about sort of like just before that, you saw an amber alert arrive, and then all of a sudden the bars shot up, and of course we were expecting a very big storm that was going to last possibly for nearly 24 hours. But as you can see, it started at 1600, but between 3 and 4 o'clock, so it was still daylight. So that was a bit of a disappointment. And what happened was, as we could see, it grew, then it dropped down again. Oh no! Then it grew again, but by this time, we were getting in towards the twilight and the dark hours. Now the thing is that because we knew this was coming. This was from an event that had happened on the sun about 3-4 days before. And what we need to actually look at is what we... so I've got to go back, so I got these in the wrong order. So when we talk about the sun, what are we actually looking at? If you've got a quiet sun, what you normally get is just a solar wind. Or you may get high-speed streamers and interplanetary shock waves from small events that happen on the sun. So these will keep us bathed in the solar winds normally during the normal times and all that, but we won't be seeing anything spectacular happening. Then we get to an active sun. Now, when you get an active sun, we're looking for solar flares. And these release X-rays and radio bursts traveling at the speed of light. So, like we were talking in my previous talks about the sun, the Carrington event, Mr. Carrington and Mr. Hodgson were both viewing the sun at the time, and they saw a massive white light. And that was the solar flare that had happened 8.5 minutes earlier. So, traveling at the speed of light, it had taken 8.5 minutes to arrive here. Well, of course, at the time, he didn't, assume that there was anything special, but he did record it, and he'd made some drawings. Now, included in this, you get SEPs, which are solar energetic particles, which is the radiation, basically, which is mainly protons and electrons traveling just under the speed of light. So if you get a flare, usually you'll see the flare. If it's a white flare, it has to be a big X-class flare. Then what you will see is the sunspot area where it's coming from will suddenly brighten, and then so that'll be the actual first light arriving, and you will see a ray in the magnetometers on Earth. You will see a blip in the actual trace, and that'll be the main crochet. And then usually about half an hour later, you will get the main storm come in behind. Now, this will give us aurora, but things have to be right, and I'll get onto that a little way better. But even better, if it's associated with a coronal mass ejection, a CME. And this is where massive amounts of solar plasma and enhanced magnetic fields actually break away and erupt out into the interplanetary media. Once it's out in the interplanetary media, it becomes an ICME, which is interplanetary coronal mass ejection. And this is the actual storm that will be moving towards us. And it'll drive strong shock waves out into space. Usually they're slow moving, about 1,500 kilometers a second. Yeah, that's slow, isn't it? But they'll take about 3, 4, maybe 5 days to actually arrive at Earth. It says here 2 to 5 days. But if they're also associated, and they cause the geometric storms on Earth, but if there is also a coronal hole actually on the sun, at the time as well, and that is Earth facing, you will get the combination of all these things because when you get coronal holes, you get enhanced solar winds. Now, this is, as you can see a coronal hole here on the bottom left. And what this is all the orange area. That is where there is high magnetic action going on. So it's producing, we can actually see it. But what happens is this black area, which is the actual hole, isn't actually a hole itself. It's just where the area is a lot cooler. There's very, very little magnetic action going on there. So the radiation or the photons and all that can actually escape, because what's happening is where there's magnetic action going on, the material, the photons, and everything else, the heat, all the radiation particles and everything are being held into the next to the sun, just above the chromosphere. So they're heating it up. But where there is no magnetic action going on, it's cooler. It's like a big, massive sunspot, really, except it's not something that's broken through the surface. It's the same sort of thing. It's cooler. That's why it's black. Now, that will give us enhanced solar wind. And this will also give us, maybe if it gets really heavy, you can have a very small aurora, but it'll be right at the poles if it gets really enhanced. Well, the combination we had, and of course, as it comes out, you will see on the bottom right, this is the solar radiation that has come from a coronal mass ejection and a solar flare. And as you can see, all this snowiness on the solar radiation image is actually the radiation hitting the sensors on one of these satellites, one of the coronaspheres on the satellite. So this is what we've been expecting. We expected it. Now, of course, we're protected by Earth's magnetic field. The image on the left is wrong. The magnetic field does not emanate from the poles and then go around and to the other pole and all that. The image on the right is how the magnetic fields on the Earth are actually aligned. They come out all the way down, and you can see they actually emerge. Some of them just around the equator, and then they just pop over and that. But you can also see the magnetic field is going south to north, and I think that's quite important. That's south to north, and you'll probably right. So this is what happens when you have a coronal mass ejection or a solar storm coming towards you. You can see the storm just leaving the sun. The shock waves coming towards the Earth, which is on the right-hand side, and you can see the Earth's magnetic field defending us. You can see these magnetic field lines actually peeling back and they will flow behind us. They don't actually break away from the actual Earth itself, and they will form a massive teardrop shape, and they will be not only guiding radiation away from us, around the back of us, but also they'll be drawing some of that radiation back into the poles, and that will give us our enhanced aurora. So this is what we were hoping for. We were going to see some lovely aurora throughout the whole of the UK. But as we know, it didn't happen. So what I've got to quickly talk about is the structure of an ICME. So what you've got, I've got numbers on the top. At the top, you can see the sun. Now you can actually see on the right-hand side, basically the black line that is in front of just the Earth, that is the shock wave. Now this will drive radiation towards us. Then what you've got, if you come back towards the sun, you can see these red lines that are actually coming round to Earth. And this is magnetic lines, which are in the moving along into the back towards the sun. But this is all full of radiation as well. But what we're looking at is this coiled and this orange bit here. This is the core of the actual solar storm, and it's called a magnetic rope, and this coil is what we need to be looking at, and what's actually inside this. As I've said before, this has a magnetic structure within inside it. And what the actual layout of this magnetic structure is will dictate on whether or not what sort of storm we're actually going to have. So next on, so there we go. So what I'm going to do is I'm going to stop this. Now I've got a prop here. This very, very expensive piece of equipment. And what I'm going to have to do is I'm going to have to take off my my background, because that's how we can see it. But this was very, very expensive. I had to go and buy this special. And so here we are. Excuse the mess behind me. So
we had to club together for this, didn't we, Dad?
Well, I'm going to put a chit in. I want the money back.
Okay.
And here it is. It's a slinky. Okay. So now, when I was talking about the flux rope, or the core of the actual storm, this is the actual shape of it. It's a tunnel. Just like that. So you can see all the way through it. Now, what this is it actually leaves the sun and it forms a bow wave which comes towards us. And as I said, if this is being driven by, it's like that. It's that shape. So you've got the loop there. So what you've got is this slinky, as we call it. And what's happening is within this, it is actually full of magnetic waves, magnetic fields. Now, there are several ways that this actually works. And what happens is as it comes out from the sun, it spreads out and it gets bigger. So what's happening is these legs are still attached to the sun. And what you've got is you've got magnetic fields running around this actual slinky as it is here. And what it is, because it's round, this is going actually around the slinky like that. Okay, so it's all right. It's getting away from me. So what you've got is you've got the magnetic fields going around that way. So, or they could be going this way. This is what I mean. I think there's about 8 configurations of what you can have on here. So if it's going this way, for argument's sake, it's going south at the front. So it's coming down and then it's coming around and up at the back. So you've got south as you go through, as it passes through the earth. When you come out the back, it will be going north. Right through the middle, again, you've got magnetic fields all the way through this. Right through the middle is what you call the axial magnetic field. And this will give you your east and west field. Now, what this will do, depending upon which way it's facing, it's either going to be westwards or it's going to be eastwards. If you can see that. So if you put the pen through, if you can see the silver tip, it's that's east or that'll be west. So what you've got is south, east, west. Okay, and that's the actual structure of this magnetic flux rope. Now, trapped inside here is lots of radiation and energetic particles. They're encased in it. It's like a prison cell, and they're all whizzing around. They're going up and down these magnetic fields, and it's how this actually hits us depends on whether or not we get good aurora. Now, what happened the other day, because you've got what you need is you've got to have a south field rotation on this as it stands there. Now, they can either hit us like that or they can hit us like that. Okay, so but you've got to have that south facing rotation of the actual magnetic field. So the particles are going, and it's those that actually that's what actually causes aurora on the earth. And but you've got to have that south facing facing. So if it comes at us like that, somewhere along there you're going to have a south facing magnetic field, which will then give us a massive aurora. And depending upon how much radiation or SEPs is actually involved in this, which will then flow back into the poles through the Earth's magnetic field lines, that dictates how much aurora we get. But if it comes to us like this, there are two ways. I mean, of course, like I said, the rotation of the magnetic fields can be either way. So you can either have west, south, west, east, or east, south, west. So it doesn't matter as long as you've got a south component. But it came at us like this, in that direction. And what we were hoping is that it twisted so that we would somewhere along the line get the south concept. But what happened is this was going east, the front was going east, the back was going west, but the actual field in the center was going north. So of course that means we had no south component to actually help the aurora to actually happen. So this is why we didn't get the aurora we were hoping for. We had no south component. If it had been like that, with the south, with it being east, south, west, we would have had a beautiful aurora, and we would have seen it all the way probably down to the south coast of the UK and possibly beyond. But that is what the problem was. We had no south component of the magnetic field within the magnetic flux rope that actually came from the sun. So yes, we got all the radiation, we passed through the radiation, we had all the magnetism, but unfortunately it didn't produce the aurora because we didn't have the south facing magnetic field. And I hope that makes a bit of sense. It's a lot more involved than that, but that's what it was. We didn't have a south facing actual magnetic field, and that's what would have opened up our atmosphere to the aurora, which would have come down and gone down to low latitudes. So I hope that explains a bit why we didn't get the aurora that we were all hoping for. So I'll leave it there because it can get quite complicated. I'm sorry.
No, thank you very much, Des. I mean, for those people who might have thought that if you do get a big solar storm, it automatically means an aurora, it obviously doesn't.
Yeah.
So,
as I said before, we cannot predict what auroras are going to do because every single one is different.
It's different. Yeah. Fascinating stuff. Right. And good to see you get your slinky out, Daz. So
yeah. I'm sorry, I'll be sending a chit in. I mean, this was very, very expensive. It's an expensive bit of equipment. It's got dinosaurs on. I did show you earlier. No, it's. I'll be playing with that later on the stairs.
Obviously meant for you, Daz. So there we are. And I like the way you're handling your slinky there. Perhaps you ought to take up the accordion.
Well, I lost control of it a couple of times, so it's maybe I shouldn't.
Yeah. All right then. So I think we'll start drawing things to a close for this evening. I'd like to thank Dave Saras for being with us this evening and talking about the Florida Winter Star Party. David's had to leave us, unfortunately, due to pressing commitments, and but he will be back and at some point. So I'd like to thank Lou for his preview of the April the 8th total eclipse of the sun. Obviously, we hope that everybody enjoys it and sends their photos into the gallery at spaceodditieslive@gmail.com. And thank you to Roger, as always, for your sterling work with the Night Sky Guide and the gallery. Thank you to Daz and his slinky. First time we've seen Daz with a slinky before, but I think he handled it, like a pro, really. And Derek says, I think Daz is winding us up. No, apparently not. No, I don't know how you can wind a slinky up, actually. So there we are. So anyway, do join us next week when Keith Mosley will be presenting the final part of his absolutely fascinating series about astrometry, measuring the heavenly bodies and mapping them. If you've seen the other parts of this series, then you'll know how good it's been. If you haven't, check it out on our channel. And we shall look forward to welcoming Keith to deliver the final part of astrometry, that being part 5, next week. Not quite sure what else we've got going on next week. Guys, do you want to say anything before we wrap things up for the evening?
No. I'm going to go and play with my slinky. You
go and play with your slinky. And we know why you've got glasses now. So there we are. We'd like to thank you all for scanning the QR codes tonight. I see we've had a few scans. I'd like to thank Gerard again for his super chat. Thank you very much, Gerard. Much appreciated. And from all of us at Space Oddities, happy Easter, everybody.
Yep.
Easter is just about upon us. May you get lots of lovely Easter eggs. We'll see you after it's all over. This time next week, 8 o'clock UK, 3 p.m. EST. But until then, from all of us at Space Oddities, take care. Have a fantastic week. Look after each other. And we will see you next week. So until then, bye-bye.
Keep looking up.
Clear skies, everybody. Clear skies. Bye.